dears, welcome to Viskool. I am Zilbi, your chemistry teacher. Let's start. Today we are going to deal with the first chapter of plus 1 chemistry, some basic concepts of chemistry. Now, what is chemistry? What is chemistry? It's a branch of science that deals with the structure, composition, properties and changes associated with the matter. Okay. Now, this chemistry is very important part of our day-to-day life. It's in the food we eat, the medicines that we take. So, it's a very vital part of our day-to-day life. Now, this chemistry have different branches. Now, branches of chemistry. Which are the branches of chemistry? Yeah, inorganic chemistry, organic chemistry, physical chemistry, analytical chemistry, biochemistry, etc., etc., etc. The list goes on. Okay. Now, moving on to the topic. When we look around, we can see many things like many matter, book, water, pen. You can see all these things, right? These all are matter. Now, what is matter? What is matter? Matter is anything that occupies a space and has a mass and can be perceived with our sense organs. Okay? What is matter? That is anything that have mass and occupies a space. Okay? Matter is anything that has mass and occupies a space. Okay, matter is anything that occupies a space and has a mass, that is called matter. Okay, now this matter can be classified into two on the basis of the physical properties and chemical properties. So physical classification and chemical classification. On the basis of physical properties, matter can be classified into three: solids, liquids and gases. On the basis of chemical properties, it can be classified again into three: elements, compounds and mixtures. Okay, on the basis of physical properties, solids, liquids and gases. On the basis of chemical properties, elements, compounds and mixtures. Okay, now what are the properties of solids? Yeah, they have a definite shape, definite volume. Now let's see the properties of solids. In solids, the particles are very close to each other. You can see from the figure. In solids, the particles are very close to each other. So, the force of attraction will be very high in solids. Okay. In solids, the particles are very close to each other. The force of attraction or intermolecular force of attraction is very high in solids. And they're very close to each other, so they cannot move freely. Okay, the solids cannot move freely. They have a definite shape, definite volume, and intermolecular voids or space. Intermolecular space is very less in case of solids. Now, in case of liquids, you can see the particles are a little bit far away as compared to solids. So, solids, the particles are free to move compared to solids, and intermolecular force of attraction is less in liquids as compared to solids. Now, liquids, what are the properties of liquids? They have a definite volume, but they does not have a definite shape. Okay, these are the properties of liquids. Now, what are the properties of gas? Yeah, particles are very far from each other, right? Particles are very far from each other. So, they does not have a definite shape. They do not have a definite volume and intermolecular force of attraction. Particles are very far away, right? So, they are moving freely. So, intermolecular force of attraction will be very low. Okay, intermolecular force of attraction is very low in gas. So, let's compare and study the properties of solids, liquids and gases. In solids, the particles are very close to each other. In liquids, the particles are not that very close to each other as compared to solids. And in gas, the particles are not at all close to each other. Now, in solids, there is no freedom of movement for particles. Now, in liquids, particles are free to move. And in gas, particles are also free to move. And in case of solids, what about the volume? They have a definite volume. Liquids also have a definite volume, but gas does not have a definite volume. Okay. Now solids, what about the shape? Yeah, they have a definite shape. Now liquids and gas, they does not have a definite shape. Okay. Now in case of solids, they have a strong force of attraction. Now liquids, there's a weak force of attraction, and in case of gas, there is no force of attraction. Have you studied the properties of solids, liquids and gas? Have you understood? Hope it's clear for you. Let's move on to another topic. Okay, now we are going to discuss with the conversions. Okay, conversions of solid to liquid and liquid to gas. How are we converting solid to gas? Okay, we are taking an ice cube and we are going to melt it. okay, or we are going to heat it. What happened? This ice cube will be converted to water. Okay, now again we are heating this water. What will happen? This water will be changed into water vapor. Okay, water will change into water vapor. So how to convert solid to liquid? By heating. How to convert liquid to gas? By heating. Now how to convert this gas? How to convert gas to liquid? Gas on cooling gives liquid. Liquid on further cooling gives solids. Okay. So to convert solid to liquid, we heat it. To convert liquid to gas, we heat it. Now to convert gas into liquid, we cool it, and liquid again on cooling gives solid. This is how we convert them. Now, moving on to chemical classification. On the basis of chemical properties, matter can be classified into two: pure substance and mixtures. From the word itself, we will get the meaning, right? Pure substance, and mixtures. Mixtures, it will be mixture. Okay, it will be mixture of many substances, that is mixture. Now, pure substance can again be classified into elements and compounds. Now, the mixtures again classified into homogeneous mixture and heterogeneous mixture. Now, let's discuss this in detail. Elements. What are elements? It is pure substance. Okay, it consists of only one substance and it will be pure. Okay, that are elements. Like it consists of only one substance, like copper, silver, gold, iron. It only consists of one substance, right? So it is elements. An element is a pure substance. It cannot be broken down into simpler ones by physical or chemical means. That are the properties of elements. Okay, it cannot be broken down into simpler ones by chemical or physical means. Okay, now it is only made up of one kind of atom. It's very important. Okay, it is made up of one kind of atom. Now, what are the examples? Copper, silver, gold, chromium, zinc, magnesium, calcium, iron, etc. Now, when two or more elements combine, they form compounds. So, what are compounds? It is made up of two or more elements combined together. Okay, combined together in a fixed proportion. Like H2O. What is H2O? It's water, right? So, hydrogen and oxygen combine to form water. Now, NH3 is ammonia. Nitrogen and hydrogen combine to form ammonia. Now, what is CH4? CH4 is methane. Carbon and hydrogen combine to form methane. Okay. Can see here, it's water. It's a shape of water. Hydrogen and oxygen combined in a fixed ratio to form water. Now, NH3, nitrogen and hydrogen combine to form NH3. CO2 is carbon dioxide. Carbon and oxygen combined in a fixed ratio to form carbon dioxide. Now, what is H2O2? H2O2 is peroxide, hydrogen peroxide. So, hydrogen and oxygen combine to form hydrogen peroxide. Okay. Now, moving on to next topic, mixtures. These mixtures can be again classified, okay, on the basis into homogeneous and heterogeneous mixtures. Now, what is a mixture? Mixture is made up of two or more compounds, okay. Two or more compounds are combined together to form mixtures, okay. Two or more elements to combine to form compounds. Now, two or more compounds combine to form mixtures, okay. What is the example? Brass and bronze. Brass is a mixture of copper and zinc. Bronze is a mixture of copper and tin. Okay, you have to study an example for a mixture. Now, this mixture is classified into homogeneous and heterogeneous. Homo, hetero. Homo means uniform composition. Mixture with a uniform composition is called a homogeneous mixture, and the mixture with a non-uniform composition is called a heterogeneous mixture. Like homogeneous mixture. Imagine we are mixing a spoon of sugar in water and we are mixing it. So you can get a clear solution, right? There are no different layers and all. We can get a clear solution of sugar solution. So we can see it's a uniform solution, right? It's a uniform solution. So We can say homogeneous mixture. It's a mixture having a uniform composition. Okay, uniform composition. Or in a composition is uniform throughout the mixture. The composition is uniform throughout the mixture. What are the examples of homogeneous mixture? Ethanol, water, salt solution, sugar solution, etc. Examples of homogeneous solution. Okay, hope it is clear for you. Now, heterogeneous solution, heterogeneous mixture. What is heterogeneous mixture? Imagine we are taking a glass of water and to this we are adding sand and we are mixing it. Okay, we are mixing it up. Now, will it dissolve? Will it dissolve? No, it will form layers, two different layers, right? So, we can say they have not a uniform composition. They have different layers and all. So, such a mixture is called a heterogeneous mixture. So, what is a heterogeneous mixture? The mixtures having non-uniform composition. The constant particles are not uniformly mixed. They are called a heterogeneous mixture. What are the examples? Muddy water, chalk water in water, gunpowder. It's a mixture of charcoal, sulfur and nitrate. So, these are the examples of heterogeneous mixture. You can see different layers are there. First layer, second layer, third layer, etc. etc. This is sand in water. So, it's an example of heterogeneous mixture. Hope homogeneous mixture and heterogeneous mixture is clear for you. Now, moving on to the properties of matter. Okay, properties of matter. There are two types of properties, physical properties and chemical properties. Okay, physical properties. If the properties can be measured without changing the identity or composition of a substance, they are called the physical properties. Okay, if the properties can be measured without changing the composition or identity of a substance, they are called physical properties. Okay, properties which can be measured or observed without changing the identity or composition of a substance, they are called physical properties. What are the examples of physical properties? Yeah, color, melting point, boiling point, order, density, etc. are examples of physical properties. Okay. Now, what are chemical properties? Okay, so properties in which a chemical change occur. What is an example for a chemical property? Yeah, chemical reaction is an example for a chemical property. Okay, chemical reaction is an example for a chemical property. Now, the International System of Units, the SI system, has given 7 base units. 7 base units, which are they? Length, mass, time, electrical current, temperature, amount of substance and luminous intensity. The amount of substance, mark it, okay? It's very important. We will deal with it. Amount of substance is that important for us. Now, which are the 7 units? Length, mass, time, electrical current, temperature, amount of substance and luminous intensity. Now, let's study for the symbols of the physical quantity. Length, it is L, small letter L. Mass, it's small letter M. Time, it's small letter T. Electrical current, it's I. Temperature, it's capital T. Amount of substance is small letter N. And luminous intensity is IV. Okay, now unit and the symbol. Length is represented in meter, so small letter M. Now mass in kilogram, kg, time in seconds, small letter S. Electrical current in amperes, capital A. Temperature in Kelvin, K. Amount of substance, small, and it's represented by mole. Now luminous intensity, candela, CD. So these are the 7 base units of chemistry. Okay, on 7 base units given by SI system. So thank you guys. Bye bye.